All right, welcome back. I'm Ryan Holger with TEC. This is part 2 of the EcoBlue Axiom Vane-Axial fan and rooftop training. Doug Bear is with us again today. We'd like to do today, if you have any questions from yesterday's session that are still lingering, go ahead and send them in, and we'll ask them to Doug to begin with. Right now, we don't have any that anybody has sent in at the moment, so unless you guys have something you want to tell us about, we'll go ahead and get started here. I did change the handout section. So on the right-hand pane of GoToMeeting, when you scroll down there, if you expand the handouts, I did add the service manuals for the 48FC and 48GC. Those two are new compared to yesterday's files that were on there. And Doug will be looking at those today when we're going through some sections of the training. So Doug, we don't have any questions yet. I'm sure as soon as you start speaking, that's when the questions will come, because that's how life works. So you can go ahead and start whenever you're ready, sir.
All right, great. Thank you, Ryan. Good morning, everybody. All right, yesterday we left off talking about the new control board and dip switch settings for fan speeds. So I thought I'd back up a slide or two here. So with that, let's move into that if I can get the slide to move. There we go. All right, so this is a recap. We utilized the old central terminal board in the new product and added in the fan control section, 0 to 10 volt fan control section. So what we're going to do is go right into these dip switch settings again and recap a little bit of that, and then we're going to get into more detail on the additional 5 dip switches on the single phase board. So we'll do that, and then we'll get into some installation practices as far as roof curbs, power wiring, and as I said yesterday, we'll get into the troubleshooting as well as talking about the limit switches, manual limit to auto, and that whole issue there. All right. So again, setting fan speed on these units is done simply, and let me get my little laser pointer up here, guys. Is simple as just plugging in your VOM on DC voltage right across your VDC terminals here and switching between A, B, and C and your potentiometer. Okay, better picture here. So jump past that, when we're doing this, again, remember that the motor itself is generating the 10 volts DC, sending it back through this plug, in through the little logic circuit, and through our switch and potentiometer, and back out to the motor in a 0 to 10 volt signal for control. All right, so as we talk later today on troubleshooting, and when I talk about some of the pins and point it out on the wiring diagram, we're going to be talking about this plug right here. So I'm going to show you points to read on the 4 leads here. You can see 2 here, there's 2 underneath, and in conjunction with our 2 pins here in order for troubleshooting. And basically what we're doing in that troubleshooting scenario is we're verifying that in fact we do have 10 volts DC from the motor, and that we are getting the correct or desired output 0 to 10 volt DC back out to the motor. And then we'll talk about another harness plug that's in the fan cabinet and some other things along the way there. Okay. Again, the 3-phase board will have just 2 dip switch setup, be these 2 here, and they'll actually be perpendicular to this. The single phase has the additional 5, and that's what we're going to get into today right now and talk about how to set these up. So on a single phase unit, we're going to do the same thing with dip switch 1 that we would do on a 3-phase unit with just the 2 dip switches. And this dip switch is going to toggle you between an inch of water column external static pressure or less. So as this says here, if the external static pressure is less than an inch water column, then you want to slide switch 1 to the on position. Okay. If we have just the 2 dip switches on the 3-phase, it's a similar thing. We do the same thing, and we'll catch the detail on that too. All right. What we're going to go into today is talking about dip switches 2, 3, 4, and 5 in a little bit more detail, which basically sets the tonnage and the your fan drive selection on the unit. So when you receive a single phase unit with these dip switches set from the factory, you'll be set up when we get into the chart for 3-ton drive, high static drive, etc. If you ever run into or encounter a board that fails, these are all going to come out defaulted at the off position. So make sure that you look at the board you're changing out, look at the current dip switch settings, and then reset these on the new replacement board before starting the unit, because this is going to set your tonnage that this board is in. It's going to set the drive package and motor connection as well. So, or not connection, but combination. Okay. So just better look at the dip switches. We're going to go to the three-phase board here. Now, yesterday we talked about, okay, so we measured our static pressure, external static pressure. We took our supply static. We talked about the location. You take your return static. We talked about the location. You forget about the plus minus and add the numbers together, right, for your total external static. We also looked on the chart, and we saw that we had to add 1/10 of an inch, or for an economizer, 2/10 of an inch, if you have a single or two-stage electric heat unit. And that came up with your voltage range, which we set with the dip switches, or excuse me, not the dip switches, but the rotary switch and your slide switch. And then once that was done, and if you're on a two-stage unit, now we need to set up the low speed. Okay, so that brings us to the slide. If it's a three-phase unit, we're just going to have these two dip switches. And now we set the low speed up. Where do we want our low speed at? Do we want it at 100% of what our setting was on the ABC switch and potentiometer, or do we want it at 88%, 75, or 66%? So this is how you kind of dial in your low speed setting for heat stage 1 or cool stage 1. So, and this is giving you your SAV capability. So as we did SAV capability on our previous units through the VFDs, this is how we do it on the new EcoBlue Vane-Axial fan and board setup. Okay, so it's just that easy. You can set these switches before you adjust your rotary switch and ABC switch, or after, it doesn't matter. And again, you can do these on the fly. So hopefully does that clear that one up? Is there any questions on that before we go into the five switch setup?
We don't have any questions sent in yet.
All right. Well, if you type as fast as me, I'll give it about 20 more seconds, just in case.
That's pretty good typing.
Yeah, I'm up to 2 fingers now, so. All right, we'll move on. All right, so if you have a single phase unit, you're going to have, as we talked, the additional 5 switches. We've got the quick enable dip switch 1. So if dip switch 1 is off, dip switches 2, 3, 4, 5 don't do anything. And the heating speed remains the same as cooling. Okay. Now, let's say we've got a 3-ton unit that we got out of the box with a low static motor option. That unit should come set with dip switch 1 on, 3 on, which tells it it's what tonnage unit it is, and 5 on, which tells us that low static motor combination. So that's what 2, 3, 4, and 5 does. 2 and 3 actually, again, like I mentioned, tells the board what tonnage unit it is, and then 4 and 5 tells the board what motor option you have. So do I have a low static motor option on a 3-ton unit? Do I have a medium static motor option or a high static motor option on a 3-ton unit? Okay, so same thing down here with the 4-ton and as well as the 5-ton. So that's basically what these switches do. It will also give you voltage output during heating. And here it's either the ABC switch and the potentiometer setting. You get down here, and with this setup, this is the output you're going to have to the motor, respectively. And same thing with the 4 and same thing with the 5-ton. Okay. So it's just that simple. Any questions on that?
No, I don't
All right.
think so.
All right. Now I'm going to switch real quick the slide carousel here. Just one moment. And what I'm going to bring up is the actual service and maintenance manual that's available for download currently, correct, Ryan?
Yes, it is available. And we do actually have a question on that last slide. As soon as you flipped it over, somebody asked a question.
Sure. Go ahead, please.
All right. The question from Dragos is, what is switch and pot?
Switch and pot the switch would be that ABC selector switch, and the pot is the rotary potentiometer next to it from 0 to 100%. Now I'll go back to a slide and show you that. It may even be in the book here. I can show you. So, but that's what it is. Let me see if I can't find it in the book here real quick. Picture of the board.
Right there.
So there you go. There's your ABC. So that's the switch that it's referencing. And then that's a potentiometer right there. And what that means is, with the 5 dip switches set the way they are, and that in that top row where everything's 0 or off, what that means is the fan speed is going to follow the switch and potentiometer setting. So that's what that means. So does that clarify the question or answer the question?
I believe it does.
Okay.
Yep, you said yes.
All right, very good. All right, so the book I'm in, let me back up here. So as you download it, it will be the service and maintenance instruction. Now this particular one is for the GC. This we have the same exact one, and again, for all the Bryant folks and all the day and night folks, apologies that these slides aren't name branded here. It's just but it is kind of one size fits all, if you will. So it's easier rather than hopping back and forth between the Carrier Bryant and day and night books that I just run with this one. So, but this is the book that's available for download. Everything applies to all three units. So day and night Bryant and Carrier. Okay. So in this book, if you've downloaded it, a lot of the slides that I've shown so far regarding the board, that's where they came from. That's where all those slides came from, is out of this book. So everything that I've been talking about regarding switch settings, that's all in here, showing pictures of the potentiometer, the switch, everything else. So hang on to this book. It's a good book, good service book to have. Again, this is the label that's on the power door of the unit in the control cabinet. Okay. All right. All that I talked about on low speed fan setting, as far as the 2-pin dip switch, which would be for the 3-phase, here's your table right here. So if dip switch 1 and 2 are both off, you get 100% of the user set fan speed. And again, the user set fan speed is what you're doing here. Where did the user set ABC? Where did the user set the potentiometer? Okay. And that was based off of, as you recall, what's your CFM requirement and what's your measured external static pressure. Okay. So when you go down here, low speed 2-pin settings, again, 100%, dip switch 1's off, 2's off. You want 75% of that, 1's on, and 2 is off. And then the 5-pin, all that information is right here. So everything we talk about is right out of the book. And here's the table that I had up. So the other table had a little bit more information about user settings and things like that. That's the only difference. Okay. All right. Let's get back to this. All right. So that was, as you see, it's the same table, just pretty much minus this part of it. And this was the question, what is switch and pot? So that's what that means there. Okay. And that's what the voltage output will be during the heating mode, is where the switch and pot set. All right. So it's just that easy to set these dip switches up. That's all there is to it. It's pretty, once get your arms around that. It's very straightforward. It's quick. You know, the hardest thing to do, the most time-consuming thing, is to take your static pressure, which again is something we should have been doing all along, even with the belt drive units. It's the right way to do it. You know, the ductwork is built to handle a certain CFM at a certain, you know, a certain velocity, you know, your feet per minute of airflow, which equates into sound. So, you know, if you're running higher airflow than that duct is designed, you're going to get a lot of noise out of it. So that's why it's imperative to look at your external static pressure and set it up correctly, rather than just saying, well, you know what, I don't have any time, I'm going to set this over to C and I'm going to put this up to 100, which gives max airflow. Well, you know, that's great. You know, you'll run in heating, cooling. The motor's not going to overamp, as I mentioned yesterday, but you could have noise issues. If we're running higher air speeds than we need across the evaporator coil and cooling, we may not get the dehumidification that we need. So, and of course, with higher airflow and heating, our temperature rises are going to be lower, so you're going to have cooler discharge air. So, setting C and 100% on the potentiometer really isn't the right way to do it. You should take the time again and measure external static pressure and know what your desired CFM is. So, any questions there? We're going to move on from the dip switch settings from here.
We do have one question. Trinidad writes, how can we tell if the unit is low or high static?
That goes back to the model number. Let me see. I may have hidden that slide. Let's take a look.
There you go.
So in the model number, in this case, again, I apologize to the Bryant and Day and Night guys. It's a carrier slide, but both Bryant and Day and Night have a model number alphanumeric breakdown. Okay, so in this case, the 48 series tells us gas heat pack, GC tells us it's 2-speed, and then we start getting into you know, heat exchanger information, all that kind of stuff. So you get down to your tonnage, and then here's your, right here in position 10 on the carrier. If you got a 1 there, it's going to tell you you got a standard static. If you got a 2 medium and a 3 high. Now Bryant will be set up slightly different, as well as Day and Night, but that information is all in the model alphanumeric breakdown. This particular table you'll find in a couple places. You'll find it in the product data book, and you'll also find it in the installation book. So that's where we usually put that info. So that's how you would determine what you have. All right. Any other questions on the dip switch or static?
Yep, we have a few more that came in here. Let me expand it so I can read them all. All right, so Dragos asks, would this ECM motor ramp up if it senses higher static after initial settings are done? For example, dirty filters will make it ramp up, etc.
Great question. And the answer is no, it will not. I mean, it's not like a full variable speed motor. Like we would have, say, in a modulating furnace. If you're a carrier guy like a 59MN or a TN furnace, it doesn't do that calculation, that torque calculation that those motors do. On the furnaces, what happens is every 100th of a second, it goes out and looks at the RPM of the motor, and it looks at the amp draw. Amp draw is converted into a torque value, and between those two numbers, it calculates what the external static pressure is or what the change was that took place. Okay, this motor doesn't do that. This motor is more like the X13 type motor or constant torque motor. So, and that's why you got to know what your external static is up front, and then set it accordingly with the switch and the potentiometer. But great question. This particular setup right now doesn't do that. What I'm going to talk about a little later is a new unit kind of coming down the pipe here that basically is this unit, but it's a full inverter driven unit. So we'll have a wider control on airflow on the supply side. We'll have control of airflow with a condenser fan and of course an inverter driven compressor. So I'll kind of mention some of the highlights on that in a little bit, but thank you for the question. That's a great question.
All right. Also want to point out that the unit that we stock of the current models, we typically stock the medium static unit locally because that kind of covers the broadest range. So if you really did need a high static one, or you had something with almost no ductwork on it and you needed a low static, we would have to order that one. But the medium static, which covers 90% of the projects, that's the one we always have.
Correct. Thank you, Ryan. All right. Any other questions?
We do have a question from Antonio. How would you adjust this motor with a zoning system?
Well, you would have to set it like any zoning system. When you set up a unit, you have to set it at full CFM. So you'd have to drive all your zone boxes or dampers wide open and set up the static there. And since this really is an SAV, or we'll call it constant speed, high-low type unit, you're going to have some type of either barometric bypass or an actuator controlled bypass damper. So again, this isn't a VAV setup here. This is basically, although it's 2-speed SAV, they're constant speed.
Right, and that situation would be the same whether we had one with a VFD on it, whether we had one that was belt driven. All those things would be the same. You'd open all the dampers to wide open, set everything up for the highest CFM, and set your bypass based on that. And then when things ramp down in real life, they just happen to ramp down.
Correct.
Trinidad asks, what kind of problems does high static cause?
High static, well, a lot of different things. High static is, resistance to airflow. So if you have extremely high static, we have reduced airflow, which can cause high temperature rise, limit tripping, overheating in the heat mode. It can cause low airflow during the cooling mode, which can cause, frosting, icing of the coil. In severe cases, we start losing control of our superheat in the coil. We start flooding back to the compressor. So a lot of things. We don't get the proper air exchange into the space. So high static is it's a real killer of equipment in all different ways. That's outside of performance issues, those are the equipment issues. We're getting a lot of static and airflow questions, which is fantastic. We do offer a airflow and troubleshooting training class that I do, and we go through how to troubleshoot high static, how to troubleshoot the ductwork, how to actually size the ductwork. We go through all that. So if you've got interest in that, I'm not sure when the next classes are, of course, with this COVID-19 pause that's we have, but that class is I don't know that I can do that via webinar, Ryan, because there's a lot of whiteboard work. And
right now it's scheduled for May 7th, and I'm hoping that we're not canceling classes in May, because then that means much bigger problems are happening. So right now it's set for May 7th. We have it labeled as a residential duct system and airflow improvement class, but the principles apply to light commercial just the same. So
yes,
your commercial guys are more than welcome to come, and you're not going to be bored, I promise. It's very interactive. And then we even go out in the lab, and we can measure stuff in there and visualize it as well. So it's a great class, but it is 7 hours long, so it would be tough to do on the web.
Yeah, exactly.
I think we're all cut up.
All right, any other?
I think we're all cut up, Doug.
Okay, fantastic. Okay. All right. This is kind of a side-by-side look here, and the reason why I wanted to put this slide in is I want to talk real quick now about the limit switch issue that probably many of you have experienced so far, and that being that the manual limit switch right here on the side of the blower housing trips, and it causes a lot of different issues. So I want to go into that discussion now. That's the whole purpose of bringing this slide up here. So the previous unit, the belt drive unit, we had the main limit for airflow mounted right here. So it's right here on the blower deck. The new unit, the new Vane-Axial units have two limit switches in them. One's mounted on the side of the housing right here, which is a manual reset and trips at 160 degrees Fahrenheit. The other one is mounted either here, but most of the time it's mounted right down here on the side panel door. Okay, so we have two limits connected to it. Currently, the way they're set up, like in this picture, they're separate circuits. They're not wired in series. And that's where we're going to make the change. Currently, this particular limit, the manual reset limit, in the next slide, I should have a diagram here. That limit switch, and Ryan, can you guys see this okay?
Yeah, we can see it.
You can see that okay?
Yep. Anybody watching from a phone is going to have a problem, but everybody on a computer should be okay.
Yeah. Here we got red wires, so I'll use a red laser. So that limit is right here. And if you were to follow and trace this all out, it ultimately ends up being right back here to the transformer. So what happens if that limit that's on the side of the blower housing, if that thing trips, we're killing power right off the transformer. And in turn, that's shutting power down to what we call the Igc board, which I'm going to get into more detail on in a minute. And that's your integrated gas controller. That's going to control your fan control and auto, your gas valve, all those things. Okay. So what happens is if that opens at 160 degrees, it basically resets the Igc board. The Igc board is capable of storing fault codes. It will store limit faults, and I'll go through all those, rollouts, all kinds of different fault codes. But as soon as you cycle power to it, you clear them all. So what happens is the unit's out there running, and for whatever reason, a dirty filter, and I'll talk some more about some of the reasons, whatever it is that caused that limit to trip, now it resets the Igc board. Now you as a service tech go out to the site, you open up the panel, you say, hey, my Igc board's got a solid red light, must be no fault codes, what's going on? And all of a sudden the unit starts up and runs. There's no history and there's no indication that it tripped on limit. So it wasn't the best plan out of the box the way they designed that. So that has since been corrected. Now what we do now, and I'll show you schematically, then we'll go back and look at the picture again, is we take this limit circuit off that blower housing. We leave the limit there, but now we take this circuit and we wire it in series with the other limit right here. So we series wire that together. Okay. Now if this guy trips or this guy trips on high temperature above 160 degrees, now the Igc will collect that information and start flashing a fault code. You'll get a fault code 2 for a limit trip. If you get consecutive fault codes, it'll go into a fault code 4, which is a limit lockout. And again, we'll go in and cover all the different fault codes here. And I've got slides and we'll point it out in the book for you as well. So that's the change on it. This change now is being done at the factory as of last week. So now all manufactured units will come out with these two limits wired in series, and this limit will be an auto reset limit. Okay. Now I believe I attached a bulletin, or Ryan, I think I gave you that bulletin for download.
Correct. So of those 5 handouts, when you expand the handout section, one of them is labeled as bulletin, and that's the one Doug's talking about right now.
Yes. So in that bulletin, it will explain this rewire that you can do in the field. It will give you the part number for the limit switch. It literally takes you like 10 minutes to do. So you pull the 2 wires off of this limit, use a butt splice on it, and then you cut one of the wires over here, which is, there's plenty of wire to go from here back over to there and back. So you grab one leg, usually the common leg of the limit, and you break that with this one here and just make a series circuit between the two. And there's enough wiring in the harness to achieve that. So again, it's about a 10-minute job. The first one may take you 20 minutes or half hour. You know, you got to think it through. But once you do one, it's a breeze. It literally takes 10 minutes. So that's going to correct the problem of the unit tripping on limit and you know, just completely flushing the Igc board of all of its faults. Okay, so that'll correct that. So now let's talk about why did it trip on limit. So we've got a few things going on here. One was our previous conversation about static pressure, high external statics. So high external statics, for whatever the reason is, causes restricted airflow, reduced airflow, and of course higher temperature rise. So if we've got high static, that could be an issue. The other potential issue is the gas valve. You know, did you set the manifold pressure? Gas valves aren't produced by Carrier, Trane, Bryant, Lennox, anybody else. They're produced by manufacturers of the gas valves, and typically they set those gas valves up, you know, and looking at the, you know, BTUs per cubic foot, they usually use around 777, 773, somewhere around there, BTUs per cubic foot at about a 0.60 specific gravity. Now we get that gas valve, Carrier puts it in the unit, Bryant puts it in the unit, they ship it to us, we sell you the unit, you put it on the roof in the Chicago market, and we've got 1,040, we've got 1,050 BTUs per cubic foot, and at, you know, 0.60 specific gravity or 0.58, somewhere in that neighborhood. And now these things run hot. And so bottom line is every single furnace you put in, and I don't care who the manufacturer is, every rooftop you put in, I don't care who the manufacturer is, you have got to hook up your mag gauge, your magnehelic gauge, and you've got to adjust your manifold gas pressure. You got to do it. So between that and the airflow and static, you know, that will control the temperature rise part of the equation. Inlet gas pressure on these, ideally you want somewhere between 5 to 10 inches inlet pressure, and you know 7 is usually the norm. So that's your inlet gas pressure to the unit. But again, your manifold pressure on high and low, you want to make sure you set those. And by the way, these gas valves now you do set high and low. Before on the rooftops you set high only, and through mechanical linkage there is a proportional setting for the low side in the valve. Now you got to set high and low up on these. Okay, so and basically your high pressure, your high fire pressure is going to be somewhere around 3.4 inches water column. So again, I'll show you in the book where that's at, so you have that on record. But nothing's changed with manifold gas pressure, but it's imperative that you change it or set it correctly, or at least check it. Okay, so airflow, gas pressure, those are two of the things. The other thing we see, and this isn't necessarily new to this unit, this problem's been around for a long time. We deal with it all the time with belt drive units as well, and that's strip malls. And what typically is in a strip mall is you've got supply grills in the ceiling, you got return grills in the ceiling, and usually there may be a couple ceiling tiles away from one another. So you got early morning occupancy starting after it's been unoccupied all night, and now we've got to regain, you know, say 4, 5, 6 degrees space temperature. So this thing runs and runs and runs, and now we're taking discharge air that may be heated to 120 degrees, and we're just throwing it along the ceiling right back into the return because of stratification and just because of the throw of the supplies and the proximity to the return. So if you've got short cycling of supply to return air, that can heat up our return air to above the maximum 85 degree return air temperature. And needless to say, if we're, you know, returning say 100 degrees or 110 degrees at the ceiling, and we have our normal, you know, 40 to 60 degree temperature rise, we're up over that main limit and it trips. So watch for recirculation of supply air into returns. You know, if you can get maybe a two-way diffuser instead of a four-way or whatever you got to do, if you could possibly move the returns away from the supplies. You know, it's hard to get away from temperature stratification, air temperature stratification when you have sealing, supply, and return, but at least try to separate those out a little bit to somewhat neutralize the air temperature. So as much as that affected the belt drives and tripping limits, it also affects this unit as well, and we have the same problem. Okay, so airflow is the big one on these, and then don't forget to set the dip switches, your ABC and your rotary switch. You know, if you leave it at factory settings, which is B, and roughly around 70% on the rotary, you may not have enough airflow with that particular duct design, especially if you're internally insulated duct. Think about all the, the factors that cause high friction rates, in turn causing high statics. So all those things together equate into limit tripping and problems, okay? So that's the easy side of things.
Doug,
Now,
Doug, can we do some questions first?
Yes, you bet.
All right, we got a whole bunch. George asks, do both of these limits have the same temp range? That was back when you had the blow up of the rooftop on there, and you're showing the two different high temperature limits.
Depending on size of the unit, the 5-ton will have a 60 and 60. I think the 3-ton, has a 138. Let me get back to that slide. I got to double check. I believe the 3-ton, I think this is 138 here, and this is 160. So this current manual limit that we want to change out, and the factory's changing out to auto, this will be 160 degrees always. So there will never be any change there. That'll always be 160. But the main limit over here, that one can vary from like 138 degrees up to 160. So there's 138s, there's 148s, and there's the 160s.
All right. Andy asks, and this is also related to the limit switches, should this wiring change be done in the field? I'm guessing he's asking, should you do it on every single one or only the ones you have a problem on? I'm assuming what he's asking.
I would do only the ones that you have a problem on. Many of these work. Out of all the units that go out and all the calls we get, I'm going to say that probably 8 out of the 10 calls we receive are typically setup issues. They didn't set the dip switches, the rotary switch. They didn't set the gas pressure. Once we clean these things up, we don't have any more limit trips. And we never see limit trips on jobs where they're running continuous fan. Now, continuous fan mode is really, it's a code requirement that we run continuous fan to provide our ventilation, required ventilation into the space. But there are jobs that run on auto mode, auto fan mode. Those are typically the jobs you run into the problems with. They're the auto fan applications where gas pressure or fan speed isn't set up. So, but no, I would address the ones you have problems with. And before I went through all the mess of ordering the switches, I would make sure everything's set correctly first.
All right. David asks, how are you going to know if the unit if your unit has the correction with the limits or not? So I'm assuming he's talking about when the factory makes their change. How are you going to know that you have that unit versus the old style limits?
It's everything produced after last week, which would be, what the heck week is that? I got to look at what week that is, but let me bear with me a second.
Yeah.
It would be,
so any units that are in the field now will be the older style.
10,
any units that are in our inventory will be the older
14.
style. And then eventually you'll start getting the newer ones.
Yep. I'd say anything week 14 or newer should be corrected. So how do we tell if it's week 14? We look at our serial number. If that serial number is 1420, C whatever, right? That's our alphanumeric sequence. The first two numbers are our week of the year. The next two are the year. So a 1420 would be last week. A 1520 would be this week. Okay, so if it's a 1420 or newer, should have the correction. And the easy way to do it is look at this switch right there. If you see a reset button in the middle of it, it hasn't been changed. If there's no reset button, then it is changed as an auto, and you can follow these wires and it'll be series with this limit switch.
All right, Michael asks, what was the heating output per cubic inch? I think that was asked when you were talking about the caloric values of what a gas valve factory might manufacture to versus what we might see in Chicago.
The range in Chicago, let's say the range in the Wisconsin, Illinois, Indiana, Michigan territories, the TEC territories there, run about 1020 to 1040. And the specific gravity typically is a 0.60, but we do see 0.58 in some areas. So that's what you can expect to see.
And the gas valve manufacturers are typically building for something less than that, or at least setting it for something less than that. So hence we have much gas flow on most of our projects.
Right, and what they did is they grabbed a BTU per cubic foot that was somewhat in the middle of everything they see in the country. Is basically what I've been told on it. So, you may be right on in some areas, you may be off in others. Then you think about elevation differences, so they kind of try to seek a midpoint between all.
All right. Clinton asks, on these EcoBlue units, is there any power protection? He's comparing them to some of the larger, like 10-ton units that have VFDs, where City of Chicago power quality is causing an issue. So he's asking if there's any power protection on these small ECM-driven units.
The only thing we have is a phase monitor on the 3-phase. That's right here. So you pop that off and hook your phase monitor up. That's an accessory. That's not standard. So we do have phase monitoring, and that's a good question to segue into my next conversation. That is about 3-phase power on these that we're starting to get feedback and identify some problems. So out of the box, no, but there is an accessory 3-phase monitor available that plugs right in.
With that being said, I don't believe with these units we've been seeing any of the same problems we've been having with some of the VFD-driven units.
Well, that was my original hopes, and now we're starting to see
Got a few.
We're starting to see on the 208. So here's the next thing we're seeing. So we talked about all the other possibilities to cause limit trips in high temperature operation, right? Well, here is another thing that now we are starting to identify and really kind of hone in on, is the motor itself is shutting down under certain conditions. So the motor will shut down itself and actually lock itself up. And you can either cycle power to it, or you can reach in and give that blade a little spin and it will unlock itself. Let me shift here and go to the book. We'll go to these fault codes and some of the things that can happen. So phase failure, locked or blocked rotor. This can happen if we find one of the two things. Either we're outside of the rated voltage range on 460 volt units, and by that I mean if we've got voltage supplied to the unit that's upwards of, say, 502, 504, we're right up there at that max voltage range. We're seeing the motors lock up here. So you can give the motor a little spin. I mean, be very careful doing that, obviously, or cycle power to it and it'll unlock it. But if we have a continuous, continuous high voltage, it will just play heck with these motors. The other thing that we run into is on the 208, 230 grids. So there are multiple power grids out there that supply 208, 230 volt. There's Delta power, there's Y power, WYE. The Delta power with the high leg, so we're talking 3-phase now. So if we took our meter and measured L1 to ground, L2 to ground, and L3 to ground, if we did that on Y power on a 230 volt system, L1 to ground would be somewhere around 120, L2 to ground would be somewhere around 120, L3 to ground would be somewhere around 120 to ground. Y power works beautifully on VFDs, and works beautifully on this ECM motor, on this Vane-Axial assembly. The other type of delta power, there's a grounded B-phase delta power. So if I went L1 to ground, it'd be around 120. If I went L2 to ground, it'd be 0. If I went L3 to ground, it'd be 120. And of course, if I went in between all those, I get my 208 or 230 volts. There's a third delta that's out there that's called the high leg. Some people call it a stinger leg. Some people call it a wild leg, but it's a high leg delta. If you went L1 to ground, you're going to read 120 volts or somewhere near it. If you went L2 to ground, you're going to read somewhere around 200 volts plus. If you go L3 to ground, you'll read around 120. If you got that high leg delta, typically it's on the B phase. What we recommend doing is hooking that B phase, that high leg, up to the blue wire on your power supply. So let me get to a schematic somewhere here, and I'll show you what I mean by that. But what we're finding is that high leg delta, which it's not real common everywhere, but there are some older power supply, older infrastructures in the greater Chicago market that have that high leg, and as it caused nothing but havoc on the VFDs, now we're finding that high leg does cause problems on these motors. So what do we do? Well, what we know, is what I just told you, and what the factory's done now is they've gone back to the motor manufacturer. The motor manufacturer says, yeah, we kind of knew about all that, which was just wonderful, right? So now we have at RCD, so all the replacement motors and parts are the newer motor style that they've broadened the voltage range of it, and they've buffered that wild leg issue. So the replacement motors, if you have a job with high voltage, if you have a job with that wild leg that's causing issues of the motor just shutting down by itself off and on, we can replace that motor. All the motors you'll get now are this updated motor. Now they're working on here within a few months, once there's enough motor inventory, to put this new upgraded motor into production on the rooftop units. So this is all something that's been determined and finally verified here in the last several weeks, last 4 to 6 weeks, and of course the Carrier Bryant day and night, everybody, everyone's scrambling to get this corrected in production. But for the time being, at least, any replacement motor you get will be the updated version of software in it. So that will get rid of some of this. But that's the other thing that's causing limit lockouts that we've been chasing, because we've had reports back from you guys that, hey, the motor just isn't running. Sometimes the motor is hot, and it's like, well, let it cool off, turn the power off, and then sure enough, you turn it back on, and 9 out of 10 times it starts. Sometimes the guys will say, well, I just gave it a spin, now it's running. Well, that's all getting this locked or blocked rotor fault code to release. And typically it was because of high voltage or possibly this high leg delta power supply. So a lot of different things, and this is another thing that's causing it. And again, if you're running auto fan operation, because once the motor's up and running, for some reason on continuous fan, it doesn't seem to lock up as easily with the high voltage or the high leg delta. So long explanation there. Sorry about the rambling on it, but hopefully that answers some questions. We are working with the factory, waiting for the factory to see if we're going to receive a bulletin on this soon. We will get a bulletin out. Just trying to figure out how soon we're going to get it out. And again, unfortunately, with this COVID-19 deal, everything's being delayed and pushed back a few weeks. So, but we are working on the bulletin side of it. So, all right. With all that, any questions?
There's several people asking detailed questions about larger units related to that kind of issue in the VFD. What I'd like to do to avoid confusion is have those folks call our tech support group, because I don't want to confuse those bigger units with these small ones we're working on today. Plus, we'll go down a rabbit hole of a half an hour on just that topic. So you guys are asking,
I can.
Let's take them
Well,
off.
I can give you a 20-second answer there. The VFDs are certainly affected by that wild leg. The voltages could be adjusted within the VFDs to the newer parameters, as long as you're within a reasonable parameter of no higher than 504 on 460. The high leg delta, there isn't a VFD out there that gets along with it. Nobody's VFD works on it. The only answer is to put in a Y to delta a delta to Y transformer to correct the voltage to the unit, and it would be a transformer that would supply the entire unit. So we'll move off of that for now. And yes, 708-418-7900 is a tech support line, and just go right into commercial, and any of the guys can take you through more conversation there. So any other questions?
I think we're caught up now, though. Thanks.
Excellent. All right, so a lot of different things to think about there. So looking at these fan motors and troubleshooting them, again, this is in the book. Remember I said pay attention to that little plug on the control boards. This is just a little wiring diagram, and you can see it here. That's just basically broken out of, where did I have the other, never mind, I'll go back to that schematic in a minute here. But basically you can see here that you've got your 10 volts coming in on the orange lead from the fan motor. So that fan motor is going to send out 10 volts DC down the orange lead right into the board, okay? And you can pick up this reading right off the leg of that connection, that Molex connection. It's open enough to get a meter probe on there, and then you can either go to chassis ground or you can go to one of the other DC voltage taps on there that you typically plug into to set things up, okay? So you should always have from the motor into the board 10 volts DC here. If we look here on 2, your gray wire, that's your output. That's your speed reference output back to the motor. That's going to tell the motor how to run. So between gray and then white here, that's going to be your output reference signal. So how do we troubleshoot this thing? The indoor fan motor's not running. I know I've got a call for either continuous fan, I'm in the heating mode, I'm in the cooling mode, you know, whichever, but the fan isn't running. So one of the first things I would do is put it in fan continuous mode, so I know I've always got a signal to the fan. And I would check my orange wire to either chassis ground, to the white wire, or one of the spade terminals on the board that we use for setup. So do I have 10 volts DC here? Not 15, not 8, but 10 volts DC. So if I've got that, it's like, okay, the motor controller is generating the 10 volts. Now, do I have a signal back? And I need something. You know, I need, 4, 5, 6 volts. I need something between, say, 4 and 10 volts DC coming back on the gray wire. If I don't, then I'm going to go back and start looking at all my dip switches, make sure they're engaged. I may cycle them. You know, if this one's supposed to be on, I may go off, back on, make sure they're engaged, make sure everything's set up right. I'm going to check my circuit board for any solder cracks here, loose connections. I'm going to check my plug. I'm going to unplug it. I'm going to look at my male and my female pins here. Are they making good contact? Then you're going to have this connection, harness connector, that's going to be in the blower compartment, which is right here. Okay, so here's our control box over here, which has got this. I'm going to go into into the blower cabinet, and I'm going to look at this harness. You know, do I have my signal voltage here? If I do, and it's going back to the motor, and that motor is not running, it may be locked up from what we were just talking about earlier, or it may have failed. Something may have failed on it. Now, if I check my orange wire and I'm not getting 10 volts DC out of the motor, I'm going to do the same thing. I'm going to check all these connections here, this plug connection, this Molex plug connection, and if I'm not getting anything out of the fan motor, and I know that I got my line voltage to it, whatever it is, 208, 230, 460, single phase, 3-phase, if I've checked and verified I've got my line power to this thing and it's not generating 10 volts, then my controller, once again, is bad. So it's that easy to troubleshoot. For those of you that do residential heating, this is a lot easier to troubleshoot than it is a ECM or a variable speed motor on a furnace. So that's all there is to it. There is a jumper right here, a jumper plug. Make sure that's intact. Make sure there's nothing going on there. Again, make sure all the dip switches, if you've got 2 for 3-phase or the 7 total for single phase, make sure they're all making contact, and I would exercise them just to eliminate, because I've seen that before on boards where the switch is in the position it's supposed to be according to the setup, but by exercising the switch, all of a sudden my signal comes back. So it could be something like that. Solder joints on older units. What I mean by older is maybe a year old. When we first came out, we had a few solder joint issues at this plug point. Look at that on the board. Look at that connector and this connector. So troubleshooting is that easy. Do I have my line voltage to it? Am I getting my 10 volts DC out of it? And do I have a signal going back? Which that signal going back is going to tell you where the problem is. Is it board level or is it motor level? So nice thing about, go down here to the single phase, but nice thing about doing this class live is we go out into the lab and we actually look at these points and throw a meter on it. So, but try to explain it the best I can doing it this way here. So, and this is just a single phase version of the same thing. So the orange is still going to be your 10 volts DC coming from the motor to the board, and gray is going to be your reference signal back to the controller. And again, all these dip switches can play into it, as well as your ABC slide switch, and as well as your potentiometer. So exercise all those if we're not getting that signal back to the motor. Okay, so that's the troubleshooting of it. Pretty simple. And those are all the things that can cause your limit trip issues and motor operation issues. So, and again, we can identify if we've got the new updated wiring and limit by looking at this particular limit. Again, 160-degree trip, 40-degree differential reset. Is there a little button in the middle of it? If it is, that's a manual and this has not been upgraded. So, and again, you don't have to unless you're having problems. You don't have to upgrade it. And here's a better picture of the main limit down here. Okay. So the new fix, these will be series together. That will be auto. All right. So that pretty much wraps up the motor side of things, unless there are any questions out there. I want to talk real quickly. What kind of time do we have, Ryan?
We got about a half an hour.
Oh, outstanding. Okay. All right. I want to talk about a couple other things here now. Let's talk about some installation opportunities, we'll call it. We see a lot, I've seen a lot over the years of something as simple as the roof curb creating airflow issues. Now you think, well, how could that possibly be on just a standard roof curb? Well, it's all the positioning of the rooftop onto the curb, and it's all about the roof curb seal strips that are put on. I've been out on many jobs over the years, and I've seen just the outer perimeter get the seal strip on several jobs. And if you don't seal this cross member separating the return air from the supply air, you can get recirculation under here. So that cross member and this cross member, as well as this, all need the seal strip on it. So all this heavy dark line here, that's all seal strip that should be put on the curb. Now that's one thing that happens. The other thing that I see happen, and now let's look at this rooftop. I'm going to call this half right here, and I'm taking it, Brian, you can see the cursor, correct?
You got to move it for me to see it.
Right here?
Yep, correct.
Oh, okay. So over here where you have your condenser, fan, compressors, I'm going to call this the condenser section of the rooftop. I'm going to call this other half over here, this is going to be our air side. That's going to have our blower, our coil, the return, the supply. Anytime, and this goes for any of our rooftops, the little 3 through 12.5 ton rooftops, all the way up to 150 ton rooftops, when you set these rooftops on a curb, your air side of the unit needs to be tight against the base rail So if there's any extra play, that extra play needs to overhang over here on the condenser side. I've seen many units over the years where the rooftop was pushed this way. So the condenser side was tight against the curb, and now I've got a 2 or 3 inch gap over here that the air side's hanging over. The problem is that opens up the return of the supply air to the roof, and you can actually have a 2 to 3 inch gap hanging over the edge of the roof curb, pulling in outside air, losing our supply air. So make sure that these rooftop units are pushed all the way over in that direction of that arrow. It's pushed that way all the way, so the excess overhang is on the condenser side of it, not the air side. So I've seen a couple of those not too long ago, and many over the years. So simple things like that can cause airflow problems. All kinds of different things. Water leaks, things like that. So always, pay caution to bear in mind the tape and how it needs to be done, seal strip, and how you set the unit. Just a simple thing like that. Additionally, now you're going to see on the units a sticker that says you must use spreader bars. So think about this piece of wood slat right here as a spreader bar, if you're not familiar with that. This crate always needs to stay on top of the unit until it's lifted by a crane or helicopter and set in place. If you take this crate off and you don't use a spreader bar, what happens is a single point pole takes these straps and breaks them over the edge, and you end up wrinkling and denting the edge of the unit on all 4 sides. So there's stickers now to say you must use spreader bars. On the smaller units, you can get away with using just this wooden crate on the top, but just make sure that doesn't get taken off before you try to lift it. And I understand why it happens. The guy's thinking, well, why do I want to haul all this junk up to the roof? Now I got to take it back down. Well, there is a purpose for it. So think about that. And there'll be a little sticker located down here on the outer panel, and it will give you all the information about this. It'll give you all the information about the corner weights for the riggers. They may ask you, what are the corner weights? That information's all on that sticker, as well as an arrow and information about the placement of the rooftop on the curb itself and keeping the rooftop tight to this edge here. Okay, so simple little things. If you got pitched roofs, that's another thing you need to look at. We can get away with a little pitch, about an 1/8 inch pitch per foot from this side to that side, and still facilitate proper condensate drainage out of the rooftops. But if you got any more than that much of a pitch, an 1/8 inch per foot, you need to look at a tapered or an adjustable roof curb. And that way you can level the top out to the machine setting level. So always think about that when you're up on a roof and looking at things. So roof curbs can cause you a lot of headache. The other thing is, adapter curbs. Let's say we had a York, Train, Lennox, whoever unit on there before, we pop it off, and now we get an adapter curb that adapts the Carrier Bryant day and night to the Lennox, Train, whoever's existing curb. Those adapter curbs, of course, you put tape on here, you set the adapter curb on, then you put the seal tape on the top of the adapter curb, put the unit on that. Those adapter curbs, in some cases, can add up to 3 to 4/10 of an inch external static pressure. So always look ahead of time what you're dealing with. You may say, hey, I've got, a concentric duct setup, or just a nice duct setup, very little static pressure, but I use a curb adapter on it. And so you ordered a low static unit thinking, well, hey, I have no static in my ductwork, or it's concentric, so I go with a low static unit. Now you set it on there and it doesn't perform because you really needed a medium static unit to overcome that adapter curb. So make sure you look into all those things with adapter curbs, static capability of the unit, which one you should order. Always keep that in mind. And as Ryan pointed out, TEC stat, we stock all the medium static units, kind of placing ourselves in between there. But do know that we have low statics and we have high static units. Okay.
Hey, Doug.
converting these small, yes,
We do have some questions that relate to this section, and we have a couple that came in from prior discussions. So I'll do the
got
ones
it.
that
Okay.
I'll run this section now. Hang on, let me see. Oh, there it is. Okay. So Steve, actually, it's more of a comment, I guess, than a question. Maybe it's a question. On a recent unit he installed, there's a spacer on the curb to push it tight to the airflow side. I assume he's asking if that's normal or if you see that often.
There could be a spacer that you would insert over here, so you would hold it tight, but that would be like an HJ frame size unit. The HJs, I believe, have that little spacer plate, if that's what he's talking about.
Could be.
But bottom line, all units need to be tight back here on the air side.
Jeff points out a tip. Jeff Boucher points out a tip, and Jeff's up in Minnesota, so it's probably easy for him. But in the wintertime, it's pretty easy to spot some of these units that are not held tight because the air leaking out of those gaps is actually melting the snow in that specific spot.
Yep, exactly. Yep, yeah, it'll be dry and warm, or it's a nice place to cool off in the summer. So, but yeah, good point, Jeff.
Jesse asks, what would be the proper procedure to check static when you're using an adapter curb?
Yeah, that's a good question. So all the adapter curbs, they have a static pressure drop rating for them. So that's something that you can get from your sales TM ordering it. So that's, you have to have that conversation. Look, I need a curb adapter. What's my static pressure drop across it? And do I need a medium, high, or, low static unit? So that's something that's already been computed by the manufacturers that we use for the curb adapters, and that should be readily available information. To try to measure the pressure drop across is very difficult with the unit on there. So that's something that we get that's posted for the adapters.
Yeah, and on that note, Pat points out that some manufacturers of the curb adapters are better than others at that data, and sometimes the same adapter from two different manufacturers may not have the same pressure drop. They may have accomplished the goal a different way. So you got to look at both of your vendors that you're looking at to see who's going to be better in the pressure drop scenario for your application.
That's absolutely correct.
Let me see. There was a couple other ones. All right, so 3 different people, you don't have to change back on slides, but when we're talking about the airflow limit switch trips on the fan,
yes,
3 different people asked when you change that to the auto reset one and the different wiring, if you have to change out the circuit board for any reason. I've been answering them no, but since everybody keeps asking that question, maybe we should just say it on here.
Sure. No, there's no reason to change the dip switches or anything on the circuit board or change the circuit board. It all plugs right into the IGC. So no reason to do anything other than wire it in series per the bulletin and change it over to the auto switch.
And there's a similar but different question from Ray. And once again, I don't know why everybody always wants to replace circuit boards, but this one is, do you have to replace the board if you exercise dip switches to get a signal from indoor fan motor? I don't know why you'd replace the board.
Well, that's a good question. If you find that a dip switch just isn't fully engaged to the off position or the on position, that's one thing. But if you had to exercise it to make it work, it's hard to say. Was it just hung up and didn't engage, or do we have something that's actually on the contacts and you just kind of scraped it and now you're making, electrical path? So it could be an indication that you got a wonky board there that may have some issues with the switch.
Well, then I apologize to Ray. I thought his question was silly, but obviously there's a legit reason for it. So Ray, good question. One more question from Dragos, and I could probably even answer it. He's looking at one of the documents you sent, and there was a note on there, Y2 connection required on single-stage cooling units when integrated economizer function is desired. What does that mean, and do I need a 2-stage stat? So yes, you have to put a 2-stage stat on a single-stage unit commercially. And almost everywhere you're required to have an economizer by code now, except for Indiana. But everywhere else, So you have to put two-stage stats on all your commercial projects. Just do that all the time, no matter what, and you'll be covered. But if you don't have Y2, then you won't get an integrated economizer, which means you're not going to be able to comply with code or even get economizer function between, say, 55 and 70 degrees. And in fact, if you look at any manufacturer's commercial thermostat, I've never seen one, at least in the past decade, that makes a commercially branded thermostat that is single stage. That's not a thing.
All right.
So if you see a single stage stat on a commercial project, it's a residential stat that somebody stuck on there.
Right. Yep. And just to kind of complement that explanation on top of that, your Y1 signal, if the outdoor air is suitable for cooling, through the economizer, that Y1 signal is going to basically run cooling using outside air. Now, if that outside air isn't satisfying the space, then you get a Y2 call. That Y2 call now is routed to bring on that compressor. So now you have the compressor running with the economizer, and then the economizer will slowly throttle back down to closer to its minimum position because your compression is typically making the supply air point. So yes, like Ryan said, you absolutely need two-stage to get proper operation, even if it's a single-stage unit.
And for those that are interested, assuming we're not on quarantine, May 15th is our next hands-on economizer class. So if you're interested in diving deeper into economizers, come join us for that one.
Yep.
I think we are caught up on questions for the most part here, Doug.
Okay, very good. All right, so moving on here, all these units, the 3 through 6 ton units, as well as pretty much all of our 3 through 12.5 ton units, and the future 7.5 through 12 ton version of the Vane-Axials are all field convertible from vertical downshot supply and return. You can convert that. They come shipped, always vertical downshot. You can convert that to horizontal. And it's just as simple as taking off the horizontal panels for the supply and the return, transferring to the underside of the unit, and then hooking your duct over here. And then do know if you do an economizer, it's a special horizontal economizer that adapts onto there. But these new units are field convertible just like the old units, so nothing's changed there. Okay. We still have the through the curb access for control, for auxiliary power, for gas, and your line voltage, meaning that we can come up right through the curb. This is your air side again. This is a condenser side. So this little raised area right here is going to be located right here on the base pan. So as you put this thing together, you have your curb, you put the base pans down, and you'll have that access point here. Always make sure if you're coming through the curb, you come through the designated area. Otherwise, you can get into water problems. This little area is raised up about 3/8 of an inch off the rest of the deck of the condenser area. So if you get water, which you will from snow and rain as it comes through the condenser fan and the coils, that water will run off the deck and it won't get high enough to get up here to get into any of these connections, which these should all be seal tight, properly gasketed connections. But again, you can bring power in, you can bring gas in, you can bring a convenience outlet in, control wire in through this area. So that's still an option. Our traps, 3-inch minimum plus 1 inch for every additional inch of static. So if you have an inch of static, I would take 1 inch plus that 3-inch, you'd have a 4-inch deep trap. You know, if you had a unit with 2 inches of external static, I'd add 2 inches to the 3-inch dimension. So nothing's changed on these units. That all works the same way. Do need to be vented. So pretty simple there. Okay. Checking manifold gas pressure. They've taken the pressure tap off the gas valve, and now that pressure tap is on the manifold. On some units, the induced draft motor makes it kind of difficult to get a wrench on here to take it off. So if you have the little 1/4-inch hex socket, that's ideal to take this plug off, and you put your port on here to check your manifold gas pressure. Okay. Up here, here's your inlet pressures. That's in the book, so it gives you all the information there. If you got high pressure coming in from the meter and you need a regulator to take it down to your 5 to 10 inches manifold inlet, make sure the gas regulator is 48 inches or at least far enough away from the exhaust as possible. When you put these regulators right next to the unit, in the winter when it's extremely cold, that exhaust, as the moisture freezes, it dissipates out and can fall right on top of the vent of the regulator. So you need to either keep your regulator out here or hook a tube up to the vent port and run that somewhere away from the exhaust from the unit. That goes for all units. Matter of fact, it goes for all manufacturers because a lot of us are the same. So really not much more to talk about on gas piping outside of keeping all fittings at least 9 inches away from the unit. The purpose of keeping the fittings 9 inches away from the unit is so you can get the door off. If you put a coupling or a union or anything like that right here, now you can't get the door off because that door's got to be raised up and then pulled out at an angle. So that 9-inch clearance is for panel removal. So just a lot of little simple tips for installation. A lot of you will like this. We now have a connection in the unit. We've got a terminal block for L1, L2, L3. There's no more wire nutting wires together and putting 2 on the contactor and 1 on the fan contactor. That's gone. We actually have a terminal block on here. And let me buzz back. I don't know if I got a good picture of it. May or may not. Looks like more of the may not, but anyway, there's a nice terminal block in there now. Here you can kind of see it right there. So like I say, no more tying onto 2 pigtails. There we go. We got a block like that, non-fused. So big improvement the way I look at it. Thermostat control wires, again, humidizer control, we can do it. That's what the hum terminal is. The rest should be self-explanatory. Your heat terminals, cooling terminals, 24 volt, common. Our transformers on our 208, 230 volt units, the transformers are going to have primary taps of 208 and 230 volt. It comes out of the factory set for 230 volt. So if you're putting the machines on a 208 power supply, make sure you change your primary tap on the transformer. That will correct your secondary voltage and make everything work correctly. And that not only goes for the current units we're talking about today, but all of our rooftop units. This gives you some humidistat wiring. If you're using humidizer type units, that's a whole separate class. Up here are just some quick tips on wire sizing. Up to 50 feet, you can use 18 gauge, and you can see 50 to 75. We increase the size of 16, so 14 over 75. So, and that's nothing new with this unit. That's been around with rooftops for a while, so I just thought I'd throw that in there. So, where are we at here? Okay, so we used to have Hall effect sensors, Hall effect switches, to prove induced draft motor operation. We've since, and not just on this Vane-Axial fan unit, but prior to that, on the TCs, HCs, KCs, we went back to a pressure switch. We did this as a request from the field overall throughout the nation, because there were a lot of people that just didn't like that Hall switch and how you had to troubleshoot it. So we do have a pressure switch here. Make sure this pressure switch is mounted in the correct position like you see it here, where your pressure tube is coming out of the bottom. If you replace this or servicing or whatever, don't put this in upside down or turn it sideways, because we can get moisture in here, and if it's upside down or sideways, we can trap moisture in the switch and kind of rendering the switch non-functional. So everything is pressure switch now. In the book, and here on the slide, here's your make breaks for the pressure switch. So you'll have that on that downloaded literature as well. Okay, and there's some troubleshooting for it, which again is in the maintenance and service manual. So all this information in this slide, you can find it there. And that gives us about almost 10 minutes to talk about the Igc board really quick, the integrated gas controller. This guy does a couple things. Has nothing to do with cooling whatsoever. So if you have a cooling problem, don't change your Igc board out. It's not going to fix it. Igc board only controls the indoor fan motor in auto mode, and it controls heating functions and safeguards and has alerts for heating operation issues like limits. So that's what it does. Now, this is kind of how it's wired in. There are two Igc boards. There's one for 460 volt models and there's one for 208, 230 volt models. So make sure you get the right ones in there. You can see it monitors the limits, the rollouts. There's your pressure switch now, and you no longer have a Hall effect sensor 1, 2, 3 connector. That's gone. So basically it controls your gas valve and monitors your limits and controls your fan in the auto modes. Okay, and of course it looks at your flame rectification to prove ignition. The fault codes that it has, and we'll go through that. So the LED, you've got one red LED light on this Igc board. That should be on solid if everything is good. If it's off, well, either you don't have power to the unit, or there's some kind of hardware failure, or the LED itself has failed. So, but as far as actual fault codes, you've got fault codes 1 through 9. You see 2 here. 1's really what's called an indoor fan modification, which doesn't mean anything, and it doesn't mean that you've modified the fan. This board, when you're running in the heat mode, so let's say we're running auto fan. So when the board starts the system up, we're going to start the induced draft motor. We're going to look for pressure switch proving. Once that happens, then we're going to start the spark igniter, and we're going to energize the gas valve. Gas valve, if flame is proven, and it's flame rectification to ground, by the way, just like our furnaces, it's a microamp signal, about 0 to 5 microamp, and just like on our furnaces, 0.5 is dropout, and typically you see about 3.5 to 4 microamp out in the field when you're reading it, and it's a series reading with your meter. Okay, so so let's say we go through the sequence I started to talk about. Now we've established flames burning. That unit is going to run and heat the heat exchanger up for 45 seconds. Now, if during that period we have a limit trip, it's going to modify that timing. Now, we used to just automatically take 5 seconds off of the 45-second warm-up period. What this new board does is wherever that trip point occurred in that 45-second countdown is where it's going to shave 5 seconds off of. So in other words, let's say we got all the way up to 35 seconds on the heat exchanger warm-up period and we trip on limit, it's going to take you back to 30 seconds. And if you trip at 30 seconds, it's going to take you down to 25. 25 is the shortest warm-up period you're going to get out of it. So we've modified that a little bit. And then on the back end, on the cool down cycle, if we trip at 60 seconds cool down, then it's going to extend it out 15 seconds like before. Start extending that cool down cycle out. So indoor fan modification, when that used to be broadcasted and listed, that's what it was. It wasn't that the fan was being modified, it's the timing that was being modified. So that's 1. 2, anytime you have a fault code 2, that means you got a limit switch fault. So either that limit on the fan housing or the limit on the side of the panel, if either one of those trip, you get a fault code 2. If you get 4 consecutive limit trips, then you end up with a fault code 4. So that's how that works. If you got a flame proving fault, we didn't prove ignition for whatever reason. There's an issue with a gas valve, or sensor lead is dirty, bad connection, whatever the case may be, you'll get a fault code 3, and it will do a retry. Now that will have a watch guard on it if it locks out on a 5. So if we get multiple 3s, and as you see here on the 5, it's going to attempt for ignition for 15 minutes. If we don't get ignition, it will issue a 5 and lock out. Well, give it 3 hours and it's going to go back and retry again. Okay, So 3 is related to 5, like 2 is related to 4, okay? The next one is 6. 6 flashes means we didn't prove that the inducer was running, which would be that pressure switch. So you got the pressure switch troubleshooting here, which is in the book, okay? 7, rollout. So if we got a flame rollout from whatever the case may be, burner alignment, air in the gas, which is giving us goofy, kind of funky flame characteristics. If we got prevailing winds blowing into the exhaust, any of those things can cause flame rollout, as well as a compromised heat exchanger or something with the induced draft wheel. But typically you usually get a fault code 6 along with that or before it. So fault code 8, internal control lockout. There's a few things that cause this. Either the IGC board is bad, but before you condemn it, if your rollout circuit or your limit circuit has a ground in it, that can cause a fault code 8. If your gas valve is grounded, it can cause a fault code 8. If you change the gas valve out and you reverse the wiring, your common to your 24 volt wiring, that can cause a fault code 8. And if your ignition cable for your spark igniter, if you have that strapped to the sensor wire, which it shouldn't be, that can cause some inductance back into the logic of the IGC, and that could cause a fault code 8. So make sure we don't have any grounds, our gas valve's good, it's wired correctly, our ignition cable is kind of standalone by itself, and if all those are clean, then a fault code 8 means you probably do have something wrong with the IGC board, okay? The last one, fault code 9, temporary software lockout. Well, what the heck is that? Well, it's either EMI, electromechanical interference, or RF, radio frequency interference. And at this point, I always explain it this way. Think about your rooftop as a radio, and think about your thermostat as the antenna. And think about how we move antennas around and the old rabbit ears on TVs, if you're old enough. Think about moving those around to pick up a signal, to get in, WLS or AM 1000 or any of those things. Well, if a thermostat wire is run just right, if it's the right length and right configuration, it can act as an antenna and pick up RF signals, radio frequency signals, that could be from ham radio operators, police cars, fire trucks, ambulances, anything. Every time they key that mic, they send out a carrier wave. And if that thermostat wire is just right, it can pick that up and bring it into the board and kind of scramble the board. EMI can be from welders, plastic extrusion factories, anything like that. So if you're getting fault code 9, you've got some kind of electrical interference going on. The solution to it are Ferrite core, Ferrite, Ferrite core filter chokes, which is basically Ferrite core magnets. And you can get these online. And what you do, they're little beads, or you can get the little square ones. Take the thermostat wires off right at the unit, wrap them around or feed them through these beads and reconnect them. That magnet will grab a hold of any interference, electrical interference that's traveling in on that thermostat wire, and magically the problem goes away. So this is an old thing. It's been around forever, as long as we've had electronic control boards out there. So that's the solution to that. I've got more. I do a 3 through 25 ton rooftop class, and I get into a little more detail on this, but that's what that's all about. And it's easier to do the Ferrite beads or the Ferrite core little clip-ons than it is to reroute or change the thermostat wire routing. So that's what fault code 9 is.
Doug, we've had about a dozen questions just come in asking, what's an antenna? What's an AM radio? What's a ham radio? What are these old things that Doug's talking about?
All right. Well,
I'm just kidding.
I'm gonna say I think those are jokes. So I like it. Thank you.
No, there is a legit question on the topic though. So Robert asks, what is the output signal to the safeties on the IGC board? 24 volts, 10 volts, etc.
Sure, 24 volts AC. 24 volt AC circuits.
Awesome. We have one other question that's not related to this particular topic. to the IGC topic, but it's from earlier. Dragos asked, am I understanding correctly that there's one motor that fits all size units, and through the settings you achieve the CFM for that unit, or are there different motors for different size units?
There's some different motors for your static ranges and your voltage ranges. So your 208, 230s with some static range, and your 460 with static. So no, it's not one size fits all. There's a few different motors.
And I do believe it's one fan for all, though. Is that correct?
Yes, that is correct. Yeah, your fan
are the same.
Yeah. Yep, you got it. Now we will be going to bigger fans when we get into the 7.5 ton through 12.5 ton.
There are also some people asking for your handle on your amateur radio. I don't think they're joking. I think they're actually asking.
Yeah. HVAC rocks.
Are you joking? Or are you serious? I don't know.
It depends on if the question's serious. No, I don't have a ham radio.
I don't know what's going on.
Yeah. No, I don't have a ham radio. But no, I just last
weekend with my kids, and I had to explain to them what a ham radio was. They had no idea what was going on, or a CB radio for that matter. They had no clue. I was like, all right.
Well, fortunately, we're going back to antenna TV, so everybody's understanding the antenna part of it.
There you go.
All right, so last couple of slides, there's a table for economizer usage. You know what, guys, we're all down here with Economizer X. Everything is a J control now. You know, the 7220, that's where it's at. And even in Indiana, you should be using the 7220. I mean, why wouldn't you? It's functionality is just superb over everything else. But with that said, you can use the 7212, which is called the Economizer 4. Okay, so without getting into economizers, we'll pass that one. And that one, and that one, and those. So Ryan does a class to set all these up. I also do this in my 3 through 25 ton rooftop classes. So we go through all this detail. Wanted to get to this slide real quick before we run out of time, which I think we actually did. But system view. So I mentioned a new unit coming out. It's going to be out on the carrier side first, 48J John C Charlie. It will be a 100% inverter driven unit, as I mentioned earlier. So the compressor will be inverter driven, indoor fan motor, ECM on the condenser fan motor. And it's going to be powered by basically system view, which if any of you are familiar with ComfortLink on our applied equipment, it's very similar to ComfortLink with a lot of upgrade. So I'm hoping eventually System View will take over for ComfortLink because there's a lot of improvements as far as things like what are called prognostics. So it kind of watches if we have a limit trip, it's already recorded what happened before that limit tripped, maybe recording statics, things like that. It's just a very powerful system. But we're going to be using that most likely to drive the new JC unit. So I would look to hear on something, or hear something on that maybe towards the fourth quarter this year, but kind of an exciting new product in this 3 through 6 ton platform. And that's about it. You also, I don't know if you had a handout, I think we didn't do that, but the unit is capable of running RTU open. It's a multi-protocol board that can speak BACnet, LANWorks, into, you know, it speaks all 4 languages, Modbus. And basically your front-end system is going to talk to the RTU open controller, and the RTU open controller are going to put out commands for Y1, Y2, economizer position, take feedbacks like supply air temperature and things like that. So it's an integration board or multi-protocol board, if you will. Matter of fact, we used to call it RTU MP, MP standing for multi-protocol. So anyway, a couple minutes over. Any last questions?
We do have a few, Doug. So
right.
Antonio asks if you can upgrade from a low static motor to a medium static motor to a high static motor in the field.
I haven't tried that yet. I'm kind of that guy that says anything's possible. I would have to look into all that, you know, because there's amp draw differences, things like that. And you're taking it out of its NEC rating, which now you own the product. So, but I haven't actually tried that yet or looked at part numbers, but I know that the aluminum housing here is the same, inlet's the same, the fan's the same. You know, it makes sense that we could do that, but electrically I'd have to look deeper into it.
All right. Steve actually has a comment that you probably can address. When checking for proper rotation on three-phase units, you cannot depend on looking at the fan in these units. You got to check the compressor rotation.
That is 100% correct. So any ECM motor or VFD bearing unit will always have a correct rotation, provided it's programmed right, will have correct rotation of that motor. So three-phase units like this, you need to look at the condenser fan, and you need to have some refrigeration gauges on your compressor to make sure it's running correctly, the correct rotation. So yes, never just trust looking at indoor fans nowadays with VFDs or ECMs.
All right, Peter was asking, what are the proper set points for a W7220 economizer, motor set point, 2-speed, all that stuff? We actually have an entire video on that on our YouTube channel, so you guys can check that out if you need help with that. We also have the class, obviously, but the YouTube video will help you immediately, so you can check that out.
Right.
Michael,
we could add more to that, Ryan.
Oh yes.
But let's just add on to that. When you're setting your low speeds, remember your dip switches. Remember it's you know, where you set 1 and 2. You are 88%, 75% of the user settings. So you would have to look at your user settings to determine your CFM points on your 7220 setup.
Michael asks, not sure if he heard correctly, but can a polarity issue cause a fault code 8?
Yes, the polarity on the gas valve. So if you change the gas valve out and you swap your common with your W1, it will look at that W1 output on the board as a grounded condition, because your common wire is going to go back to the grounded transformer. So it's not a power polarity issue. It's reverse wiring the gas valve.
I think that we've gotten all of the questions addressed. I think we're good.
All right. Well, I want to thank everybody for hanging in there. I know we went a few minutes past, so hopefully this was helpful, and we'd appreciate your feedback on these webinars. We can do more of them. You know, unfortunately, we lose the show and tell with parts and in the lab part of it, but yeah, any feedback we can get if you guys would like to see more of these on the service side. I know Ryan does a ton of them on the sales side, but if you'd like to see more on the service side, let us know.
And in regards to the show and tell, we also do have videos on our YouTube channel that are specifically for the Vane-Axial fan, where we actually take it apart and show you all the individual components, show you exactly how to do the dip switch settings on the fan speed and the potentiometer, show you how the condenser fan comes apart. So we have those videos on our YouTube channel as well. If you just go to YouTube and just search for TEC Tube, our whole channel will come up, and then there's playlists on there where you can check out different categories of things, rooftops, furnaces, thermostats, whatever. All right, well, everyone, thank you for your time. We did record this, so if you got a coworker who needs to see it, it'll be posted up on our website in about 3 hours or so. Thank you guys for your time, and thank you for helping us out today, Doug.
You bet. You guys have a blessed day. Take care.